Hi, we're going to do one more truth table with 2 variables, and then our next example will have 3. So to set up this truth table, we realize we have P's and Q's. Please try to do P first and then Q. And then we have negation of P and negation of Q both in there, so we'll put those in that order also. Again, P and then Q. And then we have a set of parentheses, so we need to add that. And then we need the whole thing. And by us splitting it up this way, we are able to test every piece of this statement. All right, so please try to do like P first and then Q. And then let me give myself lines since I'm not on lined paper. And remember, P goes true, true, false, false. And Q alternates, true, false, true, false. And we always start with true. We want to be positive. Negation P is going to flip P's value. So false, false, true, true. Negation Q flips Q's value. False, true, false, true. Oops. And then we have our first compound statement. So this is a conjunction with P and with not Q. So these are the only columns that we're going to try to look at. And we have to remember how conjunctions work. It's an and. The only time an and is true is when they're both true. So if we just scan across here, the only time, this one right here, this is the only time we're true is when we're both true. So let me erase all this mess I've done. And so we have a false. This is the one case right here where they're both true. And then false, false. And now this last statement is another compound statement. And it's dealing with that set of parentheses that we just looked at. And negation P. Those are the 2 columns we're focusing on. And it's a disjunction, so it's an or. Ors are true as long as one of them, at least one of them is true. So the only time an or is false is if they're both false. So for an or, we're just saying, are either one of these true? Actually, yeah, let's look across. Both are false, so that's a false case. One of them's true, one of them's true, one of them's true. As long as one of them's true, we get a true. So we have a false and a true, true, true. So that's our answer column. Okay, so now let's try a truth table with 3 variables. So this is example 5. We have P's, Q's, and R's. Like it says, P is the simple statement, Susanna is home, or Santana is home. Q is Santana is at his desk. R, Santana is sleeping. But they want us to figure out a truth table for this statement. So for the first time, we have 3 simple statements. And they always go in alphabetical order, P, Q, R. So we're going to set up 3 columns, one for P, one for Q, and one for R. And then again, we're going to scan through and look to see if there's any negations. And there is a negation Q. And then we have that set of parentheses. And then we need the whole thing. If you have trouble deciding what all columns you need, please try to ask me about it when we're together again Wednesday. See if I can get this to fit on a line. 1, 2, 3, 4, 5, 6, 7. Perfect. Yay. We actually need 8 lines for these 3 variables. And I'll show you why. I'll show you how we have to set them up. They're really not that bad. There's just an order again. So it's alphabetical order. P still does all the trues and then all the false, but now there are 4 true. And we want all 4 true and then all 4 false for P. And then Q still alternates, but it alternates by 2s. So Q goes true, true, false, false, true, true, false, false. And R alternates every other one. True, false, true, false, true, false, true, false. So the more we do, the more automatic that'll get. P is 4 true, 4 false. Q alternates by 2. 2 true, 2 false, 2 true, 2 false. And R alternates every other one. True, false, true, false, true, false, true, false. Okay. Negation Q, all we do is look at the Q column and flip it. So false, false, true, true, false, false, true, true. Nothing else is really different. It's just setting up the table to begin with. And now we're going to do a conjunction that involves P and negation Q. So we're going to try to scan just down these columns. And we're going to try to remember what a conjunction does. For an and to be true, they both have to be true. So we're looking for both trues. And I see both true here, and that's it. So I've got to erase all these arrows, but it was false, false, and then we had a true where they were both true on these two, and the rest of those were false. Okay, finally, we get to the answer column. And for the answer column, we're comparing that set of parentheses and R, and we're comparing them with an or again. An or again. So for an or to be true, all we need is at least one of them to be true. So if we can focus on these 2 columns, I am going to leave these circled this time. We want to look for the ones where at least one is true. At least one is true. Okay, so these are the ones that get our trues, because at least one of them is true. The others are false. So if you break them down step by step, they're really not that bad. There's another way to get a truth value, and that is without making a truth table. So this is nice also. What if we had a statement P, let's say example, determine truth values without constructing a truth table. And we will get to do some of these on the test because you're going to love these. So let's say the P statement is 2 plus 3 is equal to 5. And the Q statement is 1 plus 1 is equal to 3. And the statement that we're going to try to figure out is P and Q. So we're going to try to get the truth value of this statement without doing a truth table. First off, you've got to look at P and decide, is that a true statement or a false statement? Well, 2 plus 3 is 5. That's true. So P's true. Then look at Q. Is this true or false? 1 plus 1 is not 3. That's false. Now we take our statement, and under P, we write P's truth value. Then we bring down the conjunction, and under Q, we write Q's truth value. And then you think, for an and, for a conjunction, what makes an and statement true? Well, it's if both are true. Well, we don't have both true here, so this is immediately false. I think these are fun. I sort of like them. let's see. I think I have one more for you without a truth table. Let's just do the same statement there, and let's figure it out if we're dealing with P or Q. Okay, well, P is still true because it's the same value here. 2 plus 3 is 5. Or Q is false. And now we have to decide for this disjunction, is this going to be enough to make it true, or is this a false? Well, with ors, for ands, you have to have both true to be true. But for an or, at least one of them has to be true. So this is true. All right, last one. P is 1 million is greater than 1 billion. And Q is 1 million is equal to 1 billion. And we want to come up with a truth table for P or Q and not P. Okay. But we don't, not a truth table, just a truth value. So let's decide about P. Is 1 million greater than a billion? No. P's false. What about Q? Is a million equal to a billion? No, that's false also. So let's go through here. In the parenthesis, P's value is false, or Q's value is false. And then we have our and negation P. Negation P, let's see, well, P's false, so negation P is true. Okay, now let's work in the parentheses. False or false. Ors are true if at least one is true. Neither of these is true, so it's false. Bring down your and your T. I don't really need those parentheses. They're not doing anything. And then for a conjunction, how does a conjunction work? For an and to be true, they both have to be true. So this is false. Okay. That's all I've got for today. So now you can try the ones that we have listed for you on Google Classroom.